This video covers adding and subtracting rational expressions with common denominators. Adding rational expressions is really similar to adding fractions that have common denominators. So we're going to keep the denominator the same, and then we're going to add the numerators. So 1 plus 2 would give me 3, keep the denominator fourths. So in our first example, I have a common denominator of x plus 2 squared. So I'm going to keep that the exact same. Then I would add my numerators, so x plus 7 plus 3x plus 1. From this point, I would just combine like terms. So I have x plus 3x, and I have positive 7 plus 1. X plus 3x is 4x. 7 plus 1 is 8. And then I have that over x plus 2 squared. Then I just want to check if I can simplify anything. Before I do that, I am going to list any restrictions for this point. So at this point, I would not want x to be negative 2. If x were negative 2, that would be negative 2 plus 2, and that would give me a 0 denominator, which I don't want. On the top, I can factor out a 2. I can factor out a 4, which leaves me with x plus 2. If I rewrote the denominator, I could write x plus 2 squared as x plus 2 times x plus 2. And then if you notice from simplifying, one of these x plus 2's would cancel out, and I would really be left with 4 over x plus 2. Again, restriction would be that the denominator cannot equal negative 2. This second example is really similar, but first thing you want to notice is that this time we're subtracting. Our denominators still are the same. They're 2x minus 1, so I'm just going to rewrite that. In my numerators, I have 6x plus 7 minus 2x plus 9. So I'm just going to rewrite that. I'm going to want to keep them in parentheses for now. Something really important is that you would need to distribute this negative 1. And once we do that, then we can drop our parentheses. So 6x plus 7 minus 2x minus 9 all over 2x minus 1. Just like last time, we're going to combine any like terms. So I would have 6x minus 2x, positive 7 minus 9. When I combine those terms, I get 4x minus 2 over 2x minus 1. At this point, I would want to list any domain restrictions. So 2x minus 1, it can't equal 0. And if I were to solve this, I would figure out that x cannot be 1/2. Then I want to see if I can factor anything out. So if I check my numerator, I could factor out a 2 from both terms, leaving me with 2x minus 1. Carrying down my denominator, I have 2x minus 1. And then notice these would cancel out, leaving me with just